Hey guys, just going to make a quick video here going over some facts on magnetism. So let me start up my presentation here. So some things on magnetism that you should know. So first of all, we have on the ends of magnets what we call magnetic poles, and these are the main source of the magnetic forces there. As you guys know from class, we have two types of magnetic poles, what we call a south pole and a north pole. We call them those because one end points towards the south and one end points towards the north. All magnets have at least one north and one south pole. So just like electricity, opposites attract and likes repel. Souths will repel souths, norths will repel norths, and souths and norths will attract each other. By the way, you can have just a positive charge or just a negative charge, but you cannot have, as stated above, just a north or south pole. Iron, cobalt, and nickel will be attracted to magnets. Those are called ferromagnetic because they can be turned into magnets themselves once they're in the presence of something that's already magnetic. But those are the only three elements that can do it. Iron is in steel, so most metals that you can think of often have steel in them. That's why it seems like a lot of metals are magnetic, but it's really just those three. So not copper, not aluminum, or lead, or gold, or silver, or any of those. So if you always have to have a north and south end of a magnet, what would happen if I took this magnet and I cut it in half right in the middle of the north and south? Would I have only a north and south end then? Well, no, I would have now where in the middle, I would get a new north and a new south end. And if I cut those in half, the same thing would happen. So you always have a north end and you always have a south end of a magnet there. So in order to sort of picture how these forces work, we imagine something called a magnetic field. Michael Faraday came up with this. You can't see them, obviously, and they're not real things. They represent forces. So he wrote about these invisible lines of force, which was met with resistance at first as a way to describe things. But this is now the accepted way of thinking about it. So just like we had to choose whether or not to draw electric fields as pointing towards positives or away from positives, and we chose away, we had to pick a way to decide how to draw our magnetic fields. So the way we have chosen to draw them is they come out of the North Pole and they always loop back around and they point towards the South Pole. So out of the North into the South. So away from North ends towards South ends. A good way to remember that is you want to get out of North Korea and into South Korea if you are near the border there. So where lines are closer, the field is stronger, just like as it was for electric fields. So magnetic fields are measured in something called a Tesla, named after Nikola Tesla, the same guy who the car company is named after. So the symbol for Tesla is T, and the symbol for magnetic field is B. So a refrigerator magnet, which is a pretty weak magnet, right? It only sticks on there if it's right next to it. They have a magnetic field strength of about 0.005 Tesla, just to give you an idea of what these numbers mean. If you get a really strong, what's called a neodymium magnet, those are not going to be like even the ones you have in your refrigerator at home. They sell these to like science teachers. They can really like, even pinch your skin, but those are about 1.25 Tesla. The Earth's magnetic field is pretty weak. It is 0.000031 Tesla, but enough to turn a freely floating magnet. So what generates Earth's magnetic field is most likely due to the currents of molten iron in the outer core of the Earth. We believe the iron is churning around and that is causing the magnetism. An MRI scanner can get up to 3 Tesla, and that's strong enough to do some damage by pulling things into it. That's why you got to really make sure that you are free of any potential magnetic materials before you get inside an MRI. By the way, MRI stands for magnetic resonance imaging because it uses magnets' effect on atoms to sense where the atoms are. Its original name was nuclear magnetic resonance, but people didn't like the sound of nuclear. Like, I ain't getting no nuclear device. So they changed the name to magnetic resonance imaging. Uh, so here's a picture. A classic thing a lot of people do in a science class is you take some iron filings and you sprinkle it around a permanent magnet there. And then you can literally see the magnetic field. You obviously won't see the lines that we define as pointing out of the north and into the south, but you can see the way the iron lines up along those magnetic field lines. So if you look over in the top picture there are little clusters of aligned atoms. And what aligned atoms means is their valence electrons are spinning in the same direction. We call those little clusters domains, magnetic domains. So a normal iron nail has magnetic domains, as you can see in the top picture, pointing in all different directions. So it's like there's all these different tiny little magnets in there pointing in different ways. So they cancel each other out. And so that's why a normal iron nail is a magnetic. But if you put it in the presence of a strong magnetic field, you can actually change the way those magnetic domains are pointing, and they all point in the same direction. And that's why if you put a nail on the end of a permanent magnet, then it itself becomes a magnet. And if you left it there long enough, it would become slightly permanently magnetic as well. And this I actually already mentioned, so I'm going to skip this. This gentleman here studied magnetism, but he also believed humans had a form of magnetism. His name was Franz Mesmer, and he taught about animal magnetism. And he told people, he's basically a quack, that he could teach you how to increase your animal magnetism if you wanted to attract the other humans out there. And so since Franz Mesmer came up with this, the phrase mesmerized is referred to him trying to teach animal magnetism. So maybe you've heard of something like magnetic therapy bracelets that claim to help your balance. That has no scientific basis whatsoever. And sometimes they claim to help pain as well, that it does some kind of alignment, and they claim it does something with the iron in your blood. A few things with that. The iron in your blood is locked up into compounds, so it's no longer ferromagnetic. Its valence electrons are not available to be influenced anymore. So the iron in your blood cannot be influenced by any normal magnet. If you get a strong enough magnet, you can actually still do it. But like you would need a industrial magnet to do it. Plus, actually, attracting your blood would be a bad thing. That would pull the blood to one spot. That'd be a clot. So one more thing, and we mentioned this in class, in order to draw fields on a two-dimensional page, we use two symbols here that we haven't seen before. When you see an X when we're drawing fields, that is represents that the field is pointing into the page. And a way to remember that is the tail end of a ferro, like a tail end of an arrow, like you're looking at the end of it there. And a dot, sometimes the dot's drawn inside of a circle. Sometimes it's just the dot. But the dot is a symbol for the field is coming out of the page. Think as the tip of the arrow is coming out of the page towards your face there. So that is the magnetic portion of today's lesson.